The terminal interface is a client. Underneath it, there's a server with an HTTP API, and everything the interface can do, a script can do too. That's what this video is about, running without the interface and controlling a project from somewhere else. Every time you run it, you get two things: a supervisor running your processes and an HTTP server on port 8080. The interface talks to that server. So does the command line. So can you. First, running without the interface. The T flag set to false gives you plain interleaved output on standard out, prefixed with the process name. That's the mode you want in continuous integration, or anytime output is going into a log file rather than onto a screen. Or detach it entirely. The project runs in the background, and you get your terminal back. You can reconnect later with attach, which gives you the full interface against the already running project. The flame in the corner turns into a lightning bolt, so you can tell you're attached rather than owning it. Now the process commands. List gives you the state of everything, and there are output formats for scripts as well as for people. Start, stop, restart, and scale do what they say by name. Stop takes more than one name. These are the same operations as the function keys, which means anything you do by hand you can also put in a script. Logs from outside with a tail count and a follow flag the way you'd expect. There's a raw flag too, if you want the output without the added metadata. Ports tells you what a process is actually listening on, which is more useful than it sounds when a service picks its own port or you're running several replicas. At the project level, state gives you the overview, name, uptime, how many processes and how many are running, and which files it was built from. This next one deserves its own beat. Is ready with the wait flag, blocks until every process in the project is up and healthy, then exits. That single command is the answer to a whole family of shell scripts that poll in a loop. Start the stack detached, wait for it to be ready, then run your tests. Project update reloads the configuration into the running project. Change your YAML, run it, and the processes that changed get restarted while everything else stays up. Behind all of that is a documented HTTP API. Open the server in a browser and you get Swagger. There are about 30 endpoints, covering everything we've just done plus a dependency graph endpoint and 2 WebSocket streams. The state stream is the interesting one. Rather than polling for changes, you subscribe and get pushed an event whenever a process changes state. That's what the monitor command uses, and it's what you'd build a dashboard or a desktop notification on. An open HTTP port that can start processes deserves a moment of thought. There's token authentication. Set a token, at least 20 characters, and every request needs it in a header. Set it from an environment variable or read it from a file so it isn't in your shell history. Better still, if nothing remote needs to reach it, don't open a TCP port at all. Use a Unix domain socket, which gets you file system permissions instead of network access. Or turn the server off completely with no server if you just want the supervisor. One more flag worth knowing: read only. It disables every mutating operation and stops the interface persisting your theme and sort settings. Useful when you're attaching to something shared and would rather not be the person who stopped the wrong process. Because the API has an open API description, clients can be generated from it. There's a Rust crate in the repository that does exactly that, including a typed builder for the config file itself. If you're driving process compose from another program, that's a reasonable place to start. Last video. Putting this in a continuous integration pipeline so a test run brings up its own dependencies, and the MCP server, which lets an AI assistant see and control your stack.